Suppose we have the parsing state e goes to e plus e, and we've seen it all. There's nothing more in the future to see for this particular rewrite rule. Coming from chart state B, we've previously seen B hidden tokens that aren't shown here on the left. And this is all in chart state A. I'm leaving A and B abstract so that we know how to write a general program that does this. We decided we wanted to look for e goes to e plus e all the way back in chart state B, all the way back after we'd seen B inputs. So if you view this as our input, or sort of the bottom edge of our parse tree as we're working on constructing it, these are some previous input tokens, maybe previous ints, previous pluses, maybe parentheses if we extend our grammar. And at this point, we decided, I think I'm going to see an e plus e in the future. And now we've seen all three parts of it. So conceptually, if it's as if we'd seen the e right here. Let me firm this up with a concrete example. Let's go back in time and look at where we came from. Suppose I extend our grammar so that it has both addition and subtraction. Whoa, the power, let's not get drunk. And one of our previous states in chart B had been e goes to e minus. This is where we were, and we were expecting an expression, an e. So by reduction, by prediction, we would have added in expectations to C, things like e plus e. And in fact, that's where we got this state. That's why it says from B, we brought it in chart state B based on doing the closure here. Well, now we've seen enough input to actually make a single e. We've seen e plus e, that reduces to e. So it's as if we have this e in our input, and we're going to shift over it. In some sense, this third approach, doing reduction, is like a combination of the previous two. If I've computed the closure in the past, and now we've seen enough of the input to actually use a reduction rule, it's as if I put an e in the input, and we're going to shift right over it. So I'm just going to shift my finger over one, shift it over this e. Where did this e come from? It came from here. We'd finished seeing all of its subcomponents. We now have a big E. Whoop, we're done with it. Here's the real trick. This is one of the tricky parts of doing these reductions. Note which chart state I added it to. We added it back to chart A, because I don't want to forget that we've already seen a lot of these tokens. Remember, the particular index we're using into our chart corresponds to how many of the input tokens we have to have seen so far. A was the farthest to the right. Right, B over here. We definitely want to remember that we've seen all of these tokens in order to get to this point. This is the trickiest rule, so we'll do a worked example together, and then I'll ask for your input. Let's say we have the following grammar. If you look carefully at it, there's actually only one string in the language of this grammar, A, B, B, C. But I've added some extra non-terminals so that we'll get a chance to see how BB reduces to a bigger B by applying this rule in reverse, and then we keep going and do all the parsing. Unsurprisingly, the input will be A, B, B, C, the only string in the language of the grammar. It's B-tastic. And now I'm going to work on making the chart. So let's say we haven't seen any of the input yet. We pick our starting non-terminal, and by convention, that's just the first one I mentioned. And actually, this is all there is. There's only one rule for the starting non-terminal. We haven't seen any of the input yet. And this red dot is not before a non-terminal, so there's no closure operations to do. So we're totally fine. That's our entire parsing chart state. Now let's say we've seen one part of the input. We've seen the first token, A. Well, that matches up exactly with the token we were expecting to the right of the red dot, so we get to shift over it. And now I want to go back and make sure that we're recording all the right information. Officially, we need from or position information for each one of these parsing states. So here, we came from 0. We hadn't seen any tokens yet. This rule we brought over from the previous state by shifting. It's still from position 0. There's nothing in the input that's not already visible here on the right-hand side. But now I'm going to bring in the closure. And we decided to perform the closure in state 1, so we write a from 1 here. Another way for you to think about this from or starting position is there's really one more token, the A, that would be here on the left, but I'm not including it, so that's the one token we're missing. Here, the next input token is a B, so can we shift on any of these rules? Well, this has a dot before a non-terminal, so we can't do anything here. But this one has a dot before a token, and it's the token we were expecting. We are so happy. B goes to BB from 1. Now let's make the chart for 3 characters in the input. We've seen another B So we go look back previously. Are there any shifts we could do? Oh, we could totally shift over that B. All right. So here's the moment of truth for performing reductions. We have the red dot at the end of a rule. There's nothing to the right of it, no more input to consume. So we're going to apply this B goes to BB rule in reverse. So we're going to look back to state 1. We're going to use this from information. Where did it come from? Came from state 1. And see, I could turn this BB in the input into a big B using this rule. Is there anyone who wants to see a big B back in state 1? No. Yes, there totally is. This rule here, T goes to A dot big BC, it's really looking to see a big B. But we just made one by reduction, by applying the rule in reverse. So conceptually, we could go back and say, oh, what if we'd seen this big B in the input? We've seen it right over here, A, the BB. Instead of seeing these two lowercase b's, we'd seen the uppercase B. We'd take this rule and transplant it over to this state, being careful to retain the original from information. Now let's just interpret this from information. Starting from 0 tokens, we've seen ABB in chart state 3, and those are all represented, they're all encoded in everything before the dot. In some sense, this lowercase a has length 1, and this uppercase B had length 2. Those two together add up to 3, so I don't need any more hidden tokens to be in the third chart state. So this last part where I, from here, step 1, went back over to here and found this rule, and then brought it back over here, 1, 2, 3. This 3-step process is reduction.